So here we go, guys. You guys ready? Logarithmic properties. So that's all we're doing today. Logarithmic properties. Let's not be robots. Let's see where these rules come from. Relax, relax. We're going to have a good time. We're going to have fun. All right. So let's start. It says any positive number can be written as a power of 10. For instance, really, any positive number can be written as any power as long as, like if we're talking about a positive number, then any positive power to any exponent, as long as the base is bigger than a 1. So where did this number come from? Well, look, it says here the exponents 0.4771, 0.6989, 1.1760 are all called base 10 logarithms of 3, 5, and 15. Chop, what does that even mean? That means that if I were to type log of 3, you get that 0.4717. So here's my calculator. So check it out. Oh, that's just cow. Don't worry about that. Let's clear that. So check it out, guys. If I put log 3, if you don't see a base on the bottom of it, it's a base 10. And if I push enter, look, you get 0.4771. So what does that mean? If I go 10 to that power, look what's going to happen. You get a 3. It's not just, by the way, that's because it's a power of 10, right? By the way, if you want a different base for your logarithm, click on math and look, there it is, letter A, log base. So let's say I say log base of 5, and I'm just going to put a random number. I don't know, let's see, 23 or something. So if I do that, so I get this, right? So look what happens. If I go 5 to the power of this number, okay, the reason why it's not a perfect 23, look, it's because it's cutting this off. This goes on forever. But you can pretty much say this is practically 23. What's up, Houston?
So that's basically base 10 to the power of log 3. That's the same thing as that.
Base 10 to the power of log 3. Yes. Base 10 to the power... No. What do you think? Well, if I put this, log 3, what do you think is going to happen? No, it's not going to give error.
Oh, it's going to do the log 3 first, so it's going to go 0.44. Oh, it's going to be the same thing.
It's going to be what?
It's going to do the same thing.
What's the same thing? It's going to be 3. Yes, it's going to be 3. Good job. You guys are smart. Do you see what's going on, guys? Logarithm are exponentials. I mean, they're not called that, but they carry the same properties. So, Chav, what are you getting with this? Okay, here's what we're getting with this. So when I mean the same properties, well, first, I guess let's do side notes first. What are properties of exponents? So let's do that first. Properties of exponents. Okay, here we go. Properties of exponents. So let's do something that we should know, hopefully. X squared times m cubed. Well, that just means x squared means x times x, and x cubed means x times x times x. How many x's do you see here that are being products? So that's x to the 5th. So what's the rule for a product when you're doing exponents? I'm going to write the rule right here. X to the power n times x to the power n. You're going to add up the exponents. X to the power m plus n. Do you guys remember that? Okay. Cool or not? Cool or not cool? All right. Now, when you have something like this, so x to the power 5 over x to the power 2, well, that x to the power 5 means this. X times x times x times x times x. 1, 2, 3, 4, 5. And then that x squared means x times x. How many can you cancel? Yeah, bam, bam. 2. How many x's do you see? So what's the rule? Yeah. So if you have x to the power m over x to the power n, that is x to the power m minus n. Those are your laws of exponents. And don't worry, we'll talk about the power rule, where that one comes from. So, Chav, so what are we doing here? What is this? I know 15 is the same thing as 3 times 5. So what's the point? Well, the point is that, we're trying to see if we can turn that into an exponent like this. Chav, why? So you can see the rule, like 0.4771. And then that 5 is the same thing as 10 to the power 0.6989. And because that's a base 10 and that's a base 10, that means you can just add up those exponents. So that becomes 10 to the power 0.4771 plus, 0.6989. And of course, it goes on forever, right? And that should be the same as 10 to the power 1.1760. And of course, that's what it is, right? When you add up, is it over there? Okay, let me go log 3 real quick. What numbers?
Like at base, like log 3 is equal to 0.46.
No, of course not, miss. Don't be silly. They would never ask you to. At least I hope not. No, that. Yeah, check it out. See, when you add those two numbers up, you get that 1.1760. And I know what you're saying, like Chav. I don't like. What's the whole point? Like, I don't know. Like, tell me what you're trying to say. Well, here's what I'm trying to say. Notice that 0.4471. That's your log 3. This 0.6989. I don't. I need them to. I need their A game on this. That's your log 5. Look, guys, that's log 3 plus log 5. And that was this 3 times 5. Like that, Chop, what are you trying to say? Look, they put a log here. If you do a log there, then you got to put a log there. That is like saying log and then log. Oh, okay. So look, that's a product inside. Remember we said logs are like exponents? Well, look, that means I can make this like this. Log 3, log plus log 5. So log 3 plus log 5. Chop, what are you trying to say? Well, look, log 3 plus log 5. Look, there it is. Log 3 plus log 5. That was your exponent up there. See? So,
Like if you were to technically get rid of the log, say you divided the log on both sides, it would just be
well, like, remember, logs are like exponents, so they're going to have the same properties, right? So if I were to type in log 15 in here, look at this. Log 15, I push enter. That's the same thing as log 3 plus log 5. See, that's your product rule for logs. When you multiply common exponents, you add up the exponents. So it's the same thing for logs because the logs and exponents are inverses of each other. So look, voila. See, we're not fake here. Does that make sense? So, and then that's where we do like this quotient property here. Like now try log 15 over 5. Well, this is like exponents. So that means if I try to expand this, this is like log 15 minus log 5. Why? Because, well, this is dividing. See, 15 over 5. And that's what we did when we did divide. We subtracted. Do you guys see what we're doing? M minus n? So check it out. If I come over here and I go, come on, buddy. Okay, so log, and I'll go ahead and show it like this. I'll do the little alpha thing here. And then I know 15 over, was it 15 over 5? Yeah, I know 15 over 5 is 3, but I just want to show you this instead of just typing log 3. So there it is. And now look, check this out. I'm going to go log 15 minus log 5. And OMG, like, do you guys see what's up? Of course, if you just type log 3, you're going to get the same thing because 15 over 5 is 3. See, so hopefully we're not robots. So what do we just learn just right now? Logs are literally quote unquote exponents, but it's the inverse of exponents. You know what I mean? So because they're the inverses of exponents, it has the same properties. So yeah. So what does that mean? So I'll write it right here what we can infer. Let's do one more. See how this says log of 3 to the 4th power? So that right there is like saying log, and then 3 to the 4th power is just 3 times 3 times 3 times 3. Do you guys agree that's 3 times 3 times 3 times 3? And what did we say about when we multiply? Yeah, it's like adding log 3 plus log 3 plus log 3 plus log 3. How many logs do you count? How many log 3s do you count? So combine like terms, 4 log 3. All right, so here's finally where we put all of them together. So what can we infer? It says from this, what properties can we infer? Okay, well for products, let's see, for log of A times B, we can infer that if we expand this, it is the same thing as what?
Sorry, I have a question about the last one. So log 3 to the power 4 is equal to 4 log 3?
Yes. You know, maybe we should have done the like this. Maybe we should have proved it like the other ones. So log, look, here it is, log 3 to the power 4. Sorry, guys. Let's do this really quick because it wasn't enough. It's not enough. So there it is. That's log 3 to the power 4. Now check this out. Log 3 plus log 3 plus log 3 plus log 3. Bam. Look at that. Oh, look. Let's do it one more time. 4 log 3. Bam. Oh, it's not enough. I'll stop. I'll stop. Log 3, yeah. So see, so it doesn't make sense to do this. You can't, because sometimes people are like, why can't I multiply them? It's log 3 to the fourth. Like, no, it won't work. Times. Log 3 times. I'm doing this on purpose. It's wrong. Times log 3. So if it were to be the same, it would get the same number, but we don't. See? Cool or not cool? Okay. All right. So let's see what we can infer now, guys. So what can we infer? If we have a product, log A times B, this is the same thing as writing log A plus log B. Yeah. If you have a quotient, log A over B, as long as B is not 0 or a 1. Well, I guess it could be 1, but it can't be 0. There's the same thing as log A minus log B. Let's see if we can. And then what about this one? This one's called power, the power rule for logs. Power rule. So look where that 4 was. It was up there, the exponent, and look where it ended up. Let's use our big brains. What do you think? So log A to the power B is the same thing as B log A. Good job, nerds. Cool or not cool? Yeah, there it is. And then we just give you a little rule here. Logs are exponentials. Exponentials are logs. You can go back and forth. The only difference is they're inverses of each other. So there it is. So this is something that, okay, I don't know what it is. One year I just decided to start writing arrows. And as soon as I started writing arrows, this one kid that never understood logs was like, I got it. And I think it's so silly with arrows, but I guess whatever. So I'm going to do it with arrows. So come here to the side. All this means, if you want to go from a log to an exponential, so I'm going to write the same thing. Log base b of x equals y. So start at the base. The base is always this guy right there. Base to the power of y. So I'm going to write to the power. And that equals x. Equals. Child, what does that mean? So look, let me go to exponential. EXP. So b to the power of y equals x. See? Cool or not cool? It says to the power. It says equals. So start at the base. So look what it says. Example 1. Write log base 5 of c equals 8. So start at the base. And I'm going to write, what am I going to write? 5 to the power of a is equal to c. Done. And you can do your little arrow. Oh, 5 to the power of a equals c. Oh, it works. Does that make sense, guys? All right, cool. All right. Now they want you to go the other way around. So it says write z to the power 4 equals m in logarithmic form. Okay, this is my base. That's a base. That's what you call that number. Or, it's something to the power 4. That's your base. So you're going to go log of base z of what? M equals 4. And then you can check yourself before you wreck yourself. Let's see. Z to the 4th equals m. Works. It works. See? Z to the 4th equals m. It's the argument. It's the argument of logs. So let me go ahead and make sure that we know, guys, logs are never by themselves, just like sine and cosine and tangent. So hopefully you guys are stopping that. Sometimes you guys, because you're going so fast, you're like, oh, sine, cosine. Guys, it's never by itself. It's always sine of something, a theta of x or something. So log is never by itself. It's log of something. There's always something inside of it. X, A, B, whatever it may be. Just like f. Like it's never just f. It's f of x or f of t or f of, you know what I mean? Okay. Cool or not cool? Okay. Let's keep going. All right. Here we go. Don't worry, guys. We're just doing properties. So let's see what they want. Condense the logarithm log b plus y log a, so they don't give you a base. That's fine. That means base 10 into a single log. So they just want one single log. Before I start, I'm going to circle this one. Use the power rule on that one. So I'm going to turn y log a into log of a to the power y. If you want to put parentheses like this, you can. So now I have log b plus log a to the power of y. And I want to turn this into a single log, right? What do I have in the middle? A plus. So because I have a plus, I'm going to turn this into a product. Yeah. 1 log, giant parenthesis, b times a to the power of y. Usually you want to write the a before the b because it comes before in the a comes before b in the alphabet, but that's fine, not a big deal. And that's it. See? Yeah, see? So here we go. Here we go. Example 4 here, same as example 3. So first use the power rule. So I'm going to write log, and then once you become super beast, yeah, log a to the power c minus log b to the power y. And because there's a minus sign, this is going to be a, quotient, division. So 1 log, open parenthesis, the numerator is going to be a to the power c, the denominator is going to be b to the power y. What do you think? All right, here we go. Write the expression below the single logarithmic in simplest form. Oh, we got numbers. Relax. Here we go. Log base b of 4 plus, turn that 3 into a power, log base b of 2 to the 3rd power. If you want to put parentheses, you can. You can go to the side, or you can do it here. It doesn't matter. 2 to the... Say it again. That's this one on the right-hand side is the power rule, yeah. Well, if you're beast, you can just do it in 1. 4 times 8, you know. 2 to the 3rd power, 2 times 2 is 4, 4 times 2 is 8, so this is 8. So this is log base b of 4 plus log base b of 8. You don't have to show all these details. If you can see it in less steps, go ahead and do it in less steps. What's 4 times 8? So log base b, 8, 16, 32, yeah, of 32. And that's enough. That is enough. Or for this one at least. All right. Here we go. Next one. Expand the logarithmic fully using the properties of log. Express the final answer in terms of log x. That means they want to see the word literal, quote unquote, log x by itself. So here we go. Expand it first. This is a product. 4 times x to the 5th. So I'm going to write log of 4 plus log of x to the 5th. And then I'm going to use the power rule on the log x to the 5th because it's not enough like this. It's not enough. Log of 4 plus 5. I'll stop. Plus 5 log x. And that's it. They wanted me to expand. There it is. It's expanded. Cool? Okay. Let's go to the next one. Child, what do I do? If you want, you don't have to if you see it. You can put little parentheses on the top, and while the bottom is just a single term, so it's fine. So here we go. Log. Okay, I'll wait. Log of z plus log of x squared. And if you want to put that in parentheses, minus log of y cubed. Yes, you can go fast if you want by just going and using the power rule on those. They want log x, log y, and log z by itself, so this is not enough. That's the theme today, not enough. Kendrick Lamar. Thanks, Kendrick. And then log z plus 2 log x minus 3 log y, because we're using that power rule. Cool? Cool. And that's really about as tough as it gets. Oh, okay. Well, quick side notes. Do you relax? It's not even that bad. You guys are like, ah. All right, ready? Square root of x is the same thing as x to the 1/2. Do you guys remember those deals? The radicals? Let's see. If I have the 5th root of x squared, that's the same thing as x to the 2/5, turning radicals into exponents. So what's the rule? So side note, here's the big side note. The nth root of x to the power m is equal to x m over n. if there's no number, it's known as a square root, right? And then third root and all that good stuff. Okay, so on this one, if you Delta math and textbooks have a habit of not putting parentheses, but this is should all be in parentheses. If it helps, put parentheses for the bottom one. See how I put it in purple? I'll try to color code it. So this is log x to the fifth, and then minus, and look, here it is in purple. Purple, and I'm just doing the bottom. Log z to the third plus log, and I'm turning this into an exponent, log y to the 4/3. And then let me close my purple parentheses because it's a cube root. Yep. So now I'm going to distribute the negative, and I'm going to use the power rule, guys. So bring that 5 to the front. 5 log x minus 3 log z minus, don't forget the minus, 4/3 log y, because I distributed the negative. You distributed the negative. What's up? No, it's part of just the y. See, you're talking about the cube root, the third root? It's only for the y. The z's not in it. Oh, I put a 3. Yeah, you're right. You're right. There was no 3. I confused it for a third power. It's part of the radical. Yeah, there it is. Look, it's not even there. It's not even there. Yeah, good catch. That means I'm not posting this one on YouTube. No, I'll post it. All right, there it is, guys. I fixed it. I accidentally thought that there was an extra cube there. There was no cube in there, so it's deleted. That 3 is the cube root. So now we're good. I don't see any issues now. I think we're good now. Cool, right? Okay. No, I'll post it up, miss. I make mistakes. So, haters gotta hate. All right. I won't make a mistake on this one because I'm going to make sure. Like, see how it says answer is negative 84? I already got the answer. All right. So here we go. So the answer's already there. I posted it in there just so we can verify that it's correct. It says find the numerical value of the log expression. So this is just arbitrary. They said that log A is negative 9, log B is 8, and log C is 6, negative 6. That's fine. So expand this just like before. So the top is the product. So that's just a simple one. I can just go log. And is it okay if I do 2 steps with 1 stone? So I just don't do it already. So put a 6 in the front, log of A, plus 3 in the front, log of C, minus, and let's see, that's the square root of B cubed. So that's going to be 3/2, 3 over 2, log of B. Does that make sense to everyone? All right, so there it is. Now, what is log A? Negative 9. So 6 times negative 9, like that. It's substitution. You're just substituting. Plus 3 times, what is log C? Negative 6 minus 3/2 times what is log B? 8. Okay, real quick because I see it. I already saw it happen this morning, and if I see it on the test, I'm gonna take off points. This says log A is negative 9, guys. Do not do this. Log of negative 9. First of all, that's wrong. That's error. Remember when you did domains of logs, the graph for that graph, log x looks like this, guys. So this is not possible. Don't do that. Not possible. Log A is negative 9, not log of negative 9. Do you know what I mean? You guys love to do that for sine as well. Like whenever like sine theta equals, I don't know, I'm just making this something up. Like when we did the composite argument property, sine A plus B, you guys love to go sine squared of 3 over 2, cosine. And I'm like, man, guys, stop. When do I ever do that? Okay. Don't do that. All right. There it is. Let's see. 6 times negative 9, negative 54. 3 times negative 6, 6, 12, 18, minus 18. Let's see. 2 goes into 8 4 times. 3 times 4, minus 12. I can do these pretty quick. Negative 18 minus 12, 18, 28, 30. Negative 30. So negative 54 minus 30, 54, 64, 74, 84. There it is. Negative 84. Do you see how we did it? Cool. How do we feel? It's not that bad. It's not that bad. All right, guys, take care of business. Log into Delta. That's all we're doing. We're just doing properties. And you guys did good. You guys did good.